Start this worksheet, it starts from what we did last week, where we were using the calculator a little bit and graphing some absolute value functions. So let's go ahead and look at the first one, the y equals 2x minus 4. Now, we really don't need a calculator to graph that, right? It's just a line. I could go down to a y-intercept of -4, and then I'd have a slope of +2, right? So up to over 1, I could do that as many times as I wanted to. And then I'm going to be able to graph that line for 2x minus 4. Now take a look on the calculator. Let's just, for practice, let's just go on in and type in that 2x minus 4 equation. So if you'll go to your y equals screen, remember y equals is up there at the top left on your calculator, and let's just go ahead and type in the 2x minus 4 equation that we already graphed. So I'm going to type in 2. Remember, the x is right up here next to the alpha key. It's x comma t comma theta, so 2x and then minus 4. And just so that we're all looking at the same screen here, why don't you press zoom at the very top, so zoom, and then go down to number 4. It says z decimal, so I'm going to choose number 4. And so that line looks pretty similar to the one that we just graphed. Alright, so now let's go in and actually take a look at the graph of this next one, the absolute value of 2x minus 4. So, on your calculator, go back to the y equals, and then at the top, why don't we just leave the y1 to be that line, and move your cursor down to y2. You can just press the down arrow. And then remember, to get absolute value, you're going to press the alpha key, and then window. So absolute value is under alpha window. And if you choose number 1, the ABS, absolute value, so absolute value pops there. And then right inside the absolute value, we're going to type in the 2x minus 4, like you see on your handout. And then just go ahead and press graph. And then it's going to graph that absolute value graph on top. Now you'll notice on mine, the red one is the absolute value. And the idea is, when you take the absolute value of something, what was already positive stays positive. So this part of the line over here was the positive part of the line. It was the part that was above the x-axis. And then the part of the line that was below the x-axis, or in other words, that was the negative part, the idea is when you take the absolute value, it's going to flip up because it has to become positive. So this red V shape is actually the absolute value graph. So I'm going to go over here to my handout, and I'm going to copy the part of that line that was above the x-axis. So the part that was right here is going to stay above, and then I'm going to picture flipping that part. Remember that part that used to be down here, I'm going to flip that up, so it's going to do something like that. Okay, so that would be the absolute value graph. So with that in mind, let's see if we can practice then without our calculator. Remember, the only reason we're using the calculator on these is so that we can kind of come up with some shortcuts so that we don't need the calculator. So on this next one, I'm going to graph the line negative 2x plus 3. So I've got this y-intercept of positive 3. I'm going to put on a slope of negative 2, so down to over 1 as many times as you need to. So if I were just graphing the line, it would be, oh my, that's pretty bad. It would be something like that. Okay, but remember, if I want the absolute value, I'm going to keep the part that was above, so I'm going to keep this part, right, and then I'm going to take that part that was below and flip it up. So the red part then represents the actual absolute value graph. Okay, let's try the next one. All right, I'm going to have to pause so I can let the dog out. Isn't that crazy? Let's see. Okay, so let's try and graph this next one. I'm going to put on a y-intercept of 1, and then I have a slope of 1/2, so up 1 over 2, and you can go in both directions if you want to, right? Okay, so if I were just going to graph the line, it would go through these points. It would be something like that. But if I want to turn it into absolute value, I'm going to keep the part that was positive, so I'm going to keep the part that was above the x-axis. That would be this part of the line. And then I'm also going to take this part that was below and flip it up. And if I flip it up, I can actually kind of put a point on there to help me make it as accurate as possible. So it's going to do something like this, right? Can you kind of picture that? So it's still going to turn into a V, it's just much wider, right? Let's see. Kind of hard to see the vertex. There it is. Okay, now let's go to this next one. If I were to graph just the basic line y equals x, right, isn't that just the y-intercept of 0 and a slope of 1? So it would kind of go through the center, right, like that. And then if I want to turn it into the absolute value, so I'm going to keep the part that was above over here, and then I would flip this part up, right, and it would go through the center on that side. Okay, so now what we're going to do, we're going to go into something new, but we're going to kind of take this particular graph as our basis. So go to the next page. For function transformations, it says remember the graph from number 3, the y equals absolute value of x on the previous page. Now, I know it says go ahead and put that in your calculator, and I'm going to do that in a minute, but let's just go ahead and graph it. Remember how it was a V that was right there at the origin, and it went right through the middle of the graph on that side, and right through the middle of the graph on that side, right? Now, I'll still do what it says. I'm going to put that into my calculator, so I'm going to clear out both of these. Just press clear. I'm going to move it back up to y1, and I'm going to do like this worksheet said. I'm going to put this absolute value of x into my calculator. Okay? So on my calculator, go to your y equals, and let's see, I'll clear this out so you can see what's going on. Remember, absolute value is alpha window, so I'm going to choose number 1 for absolute value and just type in an x, and then just press graph, and you'll see exactly what we have up here. Okay, so it says to label it, so remember this is y equals absolute value of x. Okay, so now I'm looking down here at number 2, and it says leave equation y1 in, move the cursor down to y2, and this time we're going to put in the equation absolute value of x plus 1. Okay, so on my calculator, I'm going to leave the y1, move my cursor, just press the down arrow, move my cursor down to y2, and this time I'm going to put in absolute value of x, so alpha window, choose the first one, ABS, so absolute value of x, and now press the right arrow to get the cursor out of the absolute value, and remember we said we wanted to put a plus 1. Okay, so on my calculator I'm going to put plus 1, whoops, only want 1 plus, let me get rid of one of those. Okay, so plus 1, and go ahead and press graph, and you can see what happens, right? So this is the plus 1. So it says let's actually put that on here. Notice this time it starts up on the y-axis at 1 instead of down at 0. So if I were to put this one on, it started right here at this point, but it was the same shape as the one we saw a minute ago, right? Where it still kind of had that same type slope. The lines almost looked parallel. It was just moved up 1. And so this says please label. So I'm going to label that one y equals absolute value of x and then plus 1. Okay, so next it says let's go and put on y equals absolute value of x plus 2. They say put that in y3. So we're going to leave the equations there that were there, right? I'm going to leave them there. So go to your y equals, move the cursor all the way down to the y3, and let's put in absolute value of x, so alpha window, and then choose the first one, absolute value, put in an x, and then remember this said we wanted to have a plus 2. Okay, so go to my calculator, and I'm going to move my cursor out of the absolute value and then put in a plus 2. You got to make sure you move the cursor out of the absolute value because we don't want that number inside the absolute value. Okay, when I press graph, this time look what happens. You see that the vertex is now at 2. I know it looks like the graph is getting smaller, but it's not. It's just that it's going off the top. It's the exact same shape. Notice it's just has its vertex up at 2. So I'm going to put that one on. So vertex right here at 2. Still looking parallel to what I had, right? Oh, that's kind of bad. Still looking parallel to what I had. Something like that. And so that was absolute value of x plus 2. Okay, now notice what it says. This time let's put in absolute value of x minus 3. So if I'm going to put in absolute value of x minus 3, I'm going to go to my calculator. Again, I'm going to leave all of those in. Just going to move my cursor down to the y4. Remember, absolute value is alpha window. Choose that first one, absolute value. Put in your x. But this time on the outside of the cursor, let's put a minus 3. Now, what would be your guess? If it's a minus out there, what do you think is going to happen with the graph? See if you're right. Look at that. Same basic V shape, right? It's just moved down there to the negative 3. All right, so I'm going to put that one on. Remember, it's the same basic shape. Notice these all just kind of have a slope of 1 or negative 1, depending on which side. And this one, remember, was absolute value of x minus 3. Okay, so here's where it all kind of comes together, right? The box, right? The all-important, what goes in the box you know is important, right? What happens when a number is added or subtracted? Make sure you notice what this says at the end of the equation, the y equals absolute value of x equation. Well, what happens is if you have absolute value of x, now I'm going to put plus c, meaning plus any constant. It might be plus 2, plus 3, plus 5, plus 7, right? If there was a plus, didn't it just move the graph up c units, right? If it was a plus 1, remember, it just moved it up 1. If it was a plus 2, remember, it moved it up 2. Okay, and then what happens if there's a minus? Well, if you have absolute value of x minus some constant, right, minus 2, minus 3, minus 5, it doesn't matter, that situation, it's going to move the graph down c units. So if c is 3, if you have absolute value of x minus 3, it's going to move the whole graph down 3 units. Okay? So this is definitely kind of the box that you want to keep in mind. This is kind of one of the big points you want to make sure that you get from today. Okay? So let's look at another scenario. This time it says, sketch the graph of y equals absolute value of x. You know what? We don't need our calculator for this. We've been doing this all day, right? Absolute value of x, remember, is the v. It hits right here at the origin, kind of goes through the middle, right? Kind of goes through the middle. There's my absolute value of x. Okay? So what number 6 says is clear all the equations from your calculator except that first one. All right? And this time, I'm going to go and put in the equation, but notice the difference here. Notice now the plus 1's on the inside. Okay? So I'm going to go to my calculator. I'm going to press the y equals, and I just need to clear all of these. Oh, look what I did. I accidentally cleared the first one, and they said not to. So on that first one, I'll go back up to y1, and I'll put in absolute value of x. So alpha window, absolute value of x. Okay? And this said on y2, we're going to put in absolute value of x plus 1. So alpha window, and choose that first one. And then I'm going to type x plus 1. And remember, this time we're putting the plus 1 on the inside. So hopefully we're going to see what's going on when you put the absolute value on the inside compared to when you put the absolute value on the outside. So go ahead and press graph. There's the original, and then there's the plus 1. Do you see what happened? It moved it over to the left. Okay, so I'm going to graph that one. So this time the vertex was right here, but it was still the same shape, right? The lines were still parallel, same width, just moved over. So that one was, let's see, that one was y equals absolute value of x. Oops, remember the plus 1 was on the inside, right? Okay. And let's go to the next one. It says this time, let's go to y3 and put in absolute value of x plus 3. Okay, so go to your calculator, leave the ones that are in there, move your cursor down to y3, absolute value, so alpha window, right, choose absolute value, and this time in the cursor we're going to put x, I forgot, was it plus 3? Yeah, we're going to put x plus 3. Keep the plus 3 in the absolute value, press graph, and look what happens. Probably exactly what you suspected, right? It's over there at negative 3. So 1, 2, 3, it's right here. Again, same basic shape. It's going to look parallel to the other ones. So remember, this one was absolute value of x whoops, I keep forgetting to put it on the inside, plus 3, right? Okay, what's my next one say? It looks like we have absolute value of x minus 2, right? So let's go absolute value of x minus 2 on my calculator. And what would you suspect? If the plus moved it to the left, don't you think the minus is going to probably move it to the right, huh? So let's put in absolute value, and then in our parentheses we're going to put x minus 2. So let's see, x minus 2 in the parentheses, and press graph, and look at that, just as we had suspected, right? So it's to the right 2. So same shape of the lines, right? Oh, that was sorry, wasn't it? Same shape of the lines, so something like that. And that one was x minus 2. Okay, so again, let's kind of summarize what we have going on here. Remember, this time we're talking about the number is on the inside. Okay, so if we have y equals absolute value, and then on the inside we have a plus c. So on the inside you have plus 1 or plus 2 or plus 3. Remember, that's the one that actually had it moved to the left. So left c units. And then if we had x minus some number, that's the one that actually moved to the right c units. So if, let me scooch that over a little bit, units. So if I had a minus 2 on the inside, it's going to go to the right 2 units. If I have a minus 5 on the inside, it's going to go to the right 5 units. Now, to me, this seems the opposite of what it should be. On the other one, this makes sense to me, right? If it's a plus, it goes up. If it's a minus, it goes down. I don't know why. To me, it seems like it should be the other way, right? Plus seems to the right because that's where the x's are positive. So in a way, I kind of remember this because to me, it's the opposite of what it should be. Now, I'm not, saying you have to remember it that way, but if that helps. So again, this is kind of one of the big deal concepts for today. So we talked about how to know if the graph is moved up or down, and we talked about how to know if the graph is moved to the left or right. So let's see what we can do. Now here's what I want you to get. Now that we've done all that with the calculator, the whole point is to be able to do these graphs without actually using the calculator. And quite honestly, it's going to be much faster. Okay? So let's kind of do some practice. Remember, this is no calculator right now. Okay? So let's take a look. Remember, if it's on the inside, right? So we're on the inside, it's right or left. And so plus, to me, it seems like it should be to the right, and it's the opposite, so it's actually to the left. So this one, we're going to go to the left 2 units. So instead of starting right here at the origin, I'm going to be over here at the left 2 units. It's still the basic shape of the graph, right? Just to the left 2 units. And it's that quick. That's how fast you can do the graph. Okay? So take a look at this one. This time, it's on the outside, right? So that means it's going to be, because of the minus, it's going to be down 4 units. Okay? So instead of starting right here at the origin, like the original one did, I'm going to move it down 4 units. So it's the same basic shape, right? Same width as always, but it's just moved down 4 units. And if it helps you, this is how I kind of judge how wide it should be. Do you see how basically the slope of these lines is a 1, right? Because every time you go through, it's kind of an up 1 over 1. Now, I mean, I'm not perfect at it, but I kind of use that to help me judge how wide this should actually be. Okay, so take a look at the next one. It's on the inside, so what would you speculate? It's on the inside, right? But it's a minus, so you could always go back and look. If it's on the inside and it's a minus, isn't that where it was to the right? Okay, so I'm going to go, instead of going through the origin, I'm going to go to the right 3 units. There I am. Notice how I'm kind of eyeing up a slope of 1 to give me an idea of, that's kind of bad, to give me an idea of how wide it should be. Something like that. Okay, take a look at our next one. Here we go. We have the plus on the outside. So remember, that was the first type up here. If it's a plus on the outside, isn't that the type where it moves up however many units? So let's see. Here we go. I'm going to move up 3 units. I guess on this one I should have said this one was right 3 units. Sorry about that. Right 3 units. Okay, so this one remember we were going up 3 units. So instead of being at the origin, I'm right here. It still is opening up, right? It's just moved up however many units. And again, I know it looks like it's a smaller shape, but I mean, if you were to extend it, I'm not saying you have to. If you were to extend it, wouldn't it be the exact same size? Ooh, that was kind of bad. Wouldn't it be the exact same size as all the other ones? Okay? So, here's where it kind of all comes together. Here's where all of a sudden you can graph things that you never even came close to graphing before, and you're going to do it in just seconds. Okay? So here's the thinking. When I actually go to graph this, I know the basic shape of an absolute value of x, right? It's the one that kind of starts at the origin, and you know, just kind of imagine it going right through the middle, right? That's my basic shape. But what's going on here is because of this minus 2, I'm going to move that same shape to the right 2 units, right? And at the same time, I'm going to move it down 3 units. Okay, so I'm going to do this all in one graph. I'm going to go to the right 2, so what used to be right here is now moved over here, and at the same time I'm going to go down 3. So now the vertex that used to be right there at the origin is down here at this point 2, 3. So I'm going to draw that exact same shaped graph, right? Just kind of eye up a slope of 1 and negative 1 on each side. And it's moved over. Now, the only reason I left that red one there is for you to get an idea of that's where we started, right? And then we went to the right. We went to the right 2 units. So we went that direction, and then we went down 3 units. Okay, so the green one is actually my final graph. All right, so on this one, so we've got that same basic shape, right? That V right there at the origin. But this time we're going to go, what's that one going to have us do? It's going to go 1 unit to the left. Okay, so left 1. And then we're also going to go, what does this plus 2 do? We're going to go up 2. So what used to be right here at the origin has been moved to the left 1 unit and up 2. So there's my new vertex. Right? I went to the left 1 and up 2. So I'm going to draw the basic shape, right, where they both sides have a slope of 1 and negative 1. And that's it. So in seconds, you can just look at it and draw the graph. Okay, so basically here's what you need to do on your own. I have several graphs. There's actually 6 of them here. And you're going to do exactly what we just practiced on this page. Right? You're going to look and see if you need to move left or right, look and see if you need to move up or down, and then just draw the graph. Okay? Remember, the most important thing that you get out of this, I mean, I know we will never know what you did to graph these, but when you come back to class and then we have them do them on your own, we will know if you use the calculator or not. Right? These you are not supposed to use your calculator. You're supposed to just look at it and draw the graph. Okay? So I hope that helps. And I hope you have a good rest of the day.